All right, let me finish up. So I hate doing this where we go somewhere into a proof. We have only a few minutes, so maybe I gave you a bunch of no's and shows, so you're gonna go back to your notes. I'm gonna now assemble my proof. Weird, right? You just like, I have to go back to where we were. So the last time I was trying to prove something, I don't even remember what it was. What were we trying to prove? We were trying to prove DeMorgans law for union, that A union B with a complement over it is equal to A with a complement over intersect B. And I was showing the one direction of that. And I had listed out all my no. So you want to pull those notes in front of you, otherwise none of this is going to make sense. So now I'm ready to assemble my proof. So I'm going to rewrite expansion 2. We start with expansion 2. Usually you have an expansion of something, you start like, it's like you have puzzle pieces that you're trying to assemble, but those puzzle pieces are in a box and you can't see those puzzle pieces. So you have to actually first open the box and take out those puzzle pieces. So every step that you have on your proofwriting wiki, I'm looking for that too on your notes. Like when you're turning in your notebook, just follow the steps, because if you get stuck, I'll know this is where you got stuck. I had my whole thing expanded, and then I'll be able to say, hey, you didn't expand it further. Here's where you need to do some work. It'll help me to help you better too. So follow those steps in the proofwriting wiki. There's actually a little screenshot right at the top of it with a little text box which has the steps laid out. Step 1, develop a numerical example. Step 2, write down your statement as if then. So everything's laid out there. And that was designed by students. Hundreds and hundreds of students. Like they came and just touched that. Even last semester, people were still editing that. You might have an edit to it. And there'll be another foundations class and I'll say, Cooper edited this. And they'll say, who is that guy? And it just makes it easier to get through if a student kind of says, this is where I'm stuck. All right, so we start with the expansion. So start with expansion 2. So I labeled everything in my notes, so I hope you have it. That was expansion 2. Okay. I can conclude from that X does not belong to this set by membership of that, right? So it doesn't belong to this set right here. I claim X is not in A, so it's not going to be in the complement of A. I'm going to do a contradiction. It is either in A or not. So I'm going to assume that it's in A. So Cooper, this is again a contradiction proof. I'm trying to show something. It's harder to show something's not in there. So I'm going to say, okay, let me do the opposite of that and come up with something that's a complete nonsense statement. Well, if X is in A, then X is in A or B. Right? I've just tacked on another set. But my hypothesis says it can't be an A or B. Ugh. Right? So by my no, that's impossible. So the opposite is true. X is not an A. I'll go back to this. And let me just keep it on the sheet. So I'll put it on the top. It's working. To do the X naught and B, it's identical. Maybe I'll have you guys take boards at the beginning of next class period, where you do the X naught and B. So once I've shown X is not in A and X is not in B, I go back to what it was I was trying to show. That's what I was trying to show. So my claim 2 will be that X is not in B, but we'll do that next time. Do we meet Friday? I think we meet Friday. That's when I need the calendar. The calendar to tell me where I'm supposed to be.